6.2, we're going to study the properties of parallelogram. So first of all, we need to understand what is a parallelogram. A parallelogram is actually a very special quadrilateral. Remember, quadrilateral has four sides. I want to make sure I spell it right, a quadrilateral. Now, a parallelogram has to be a quadrilateral like this shape, ABCD, in the sense that both pairs of the opposite sides are parallel. So AB would be parallel to CD because these two are the opposite sides. And BC would be parallel to AD because these two are opposite sides. So that's the definition of parallelogram. It's a quadrilateral with both sides of opposite sides being parallel. And here's a theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. In this example here, by the way, we use this little symbol to express parallelogram. So in parallelogram PQRS, PQ has to be congruent with SR, and QR has to be congruent to PS. Okay, let's look at an example. It says that FGHJ is a parallelogram. We have to find GH. We don't know what GH is. And we have to find FJ, which is right here. So because the opposite sides of a parallelogram are congruent, so GH, which is the top, has to be congruent to FG. Therefore, they're of the same length at 5. FJ has to be congruent to GH, and they have to be the same length. Okay, so here's a checkpoint. ABCD is a parallelogram. Find AB and AD. Because AB and CD are parallel and opposite sides, they also have to be congruent. Therefore, AB has to equal AD at 9, right? And now AD and BC have to be congruent. So AD equals BC, and they both equal 8. Okay? So let's look at the second page. Here we have another theorem that says if I have a parallelogram, then its opposite, remember the opposite sides are congruent and parallel. Now we're studying its angles. So the opposite angles are congruent, meaning this angle Q and angle S with one tick mark are congruent, and angle P and angle R with two tick marks are congruent. So P and angle R, angle Q and angle S. And the second theorem says if a quadrilateral is a parallelogram, in other words, I already have a parallelogram, we know that, then its consecutive angles are supplementary. If you recall, I think it's chapter 3 where we learned 4 sets of angles. When we have parallel lines, look at this, the one that cuts them through is transverse. So we have alternate interior, alternate exterior, we have corresponding angle, and the only one that's different is same side interior, which is also called consecutive angles. They have to add up to 180 degrees. Okay, and also notice that from this first 6.3, that theorem, we know parallelograms opposite angles are congruent. So on this side, it's also true that these two consecutive angles adds up to 180. And if you look at it sideways, these two here, I put a triangle, these two angles, because PQ is parallel to RS, these two and this two are also consecutive angles, and they add up to 180. So I'll leave the follow-up for you to do. It's a little bit challenging, but if you think through it, it really makes a lot of sense. Let's look at example 2. PQRS is a parallelogram. Find the missing angle measures. So I know if I have 70 here, this must be 70. And then I need to find Q. And if I find Q, I would have S because opposite angles are congruent in a parallelogram. So let's see. So we said that because angle R is congruent to angle P, so their angle measures must be different at 70 degrees, right? We also know consecutive angles like this, Q and P, add up to 180 degrees because I know it's already, what's in front of me is it's a parallelogram, and consecutive angles are supplementary. Now, if I substitute P with the 70 degrees that I already know, and then I do a little bit algebra, it's not that hard to find out that angle Q is 110 degrees, right? Now that I found out Q is 110, Q and S must be the same congruent angles. So to summarize, angle measure for R is 70, for Q is 110, and then for S is 110 as well. Next page. Let's see, what do we have here? Here's a follow-up. This is somewhat intuitive. You guys all know squares and rectangles really well. This is slightly different from that, but actually it's probably easier than those two as well. So finish the follow-up and finish the checkpoint. If you have questions, make sure that you ask in class. And here is the last theorem of the day and also the last example. So let's take a look here. It says, if a quadrilateral is a parallelogram, so I have a parallelogram here, then its diagonals, meaning PR and SQ, bisect each other. So diagonals bisect each other. So PM and MR are congruent, QM and MS are congruent. In other words, where they intersect at M is the midpoint. So M is the midpoint of the diagonals. So in parallelogram PQRS, QM would be congruent to MS, and PM would be congruent to MR. Okay? Now, the last example tells us I've got a parallelogram here. I need to find TX, this little bitty thing. Remember, if I have a parallelogram, my diagonals are bisecting each other. And if I know this part is 3, this part has to be 3, right? So TX is equal to VX, and it should equal 3. That's the length of TX. Okay, so finish this and then finish the IXL practices. See you guys in class. Bye.
Oh, you're rolling all over the place now. There you go. You're coming this way. Grip Grip. See, look, Grip Grip's showing you how to do it. Look at him. Do what Grip Grip's doing. Yeah, you gotta do what Grip Grip's doing. He's trying to show you. He's trying to show you. Yeah. Yeah, he's trying to show you.